Hi students, so welcome to our channel Physics to Learn here. So in previous class we have been discussed regarding the gravitation force. So regarding that chapter name we have been discussed it as gravitation. So if you have not been seen means I'm keeping at the end, just you can show in iCard and then you can watch it. So in this class we are going to discuss regarding continuation part, so that as universal gravitational constant. So while discussing gravitational force we have been discussed, so F is equals to capital G into m1 m2 by r square, where capital G is called universal gravitational constant. Now regarding this universal gravitational constant we are going to discuss. So already we know F is equals to capital G into m1 m2 by r square. With the help of this we are going to write it as capital G is equals to F into r square by m1 m2. So if you have been move this, so r square toward this side and m1 and m2 towards downwards, so which have been taken. So with the help of that, so which I'm going to get it as capital G is equals to F into r square by m1 m2, so which you can get it. So if we are assuming that m1 is equals to m2 is equals to 1 and r value is equals to 1, under such condition we can tell it as capital G which is equals to F. Universal gravitation constant is numerically equals to the force of attraction between two unit masses placed at a unit distance. Here the meaning of unit is nothing but 1. Masses are 1 and they are separated by a distance of 1. Under that conditions we can tell it as capital G is equals to capital F. So in this manner, so which we can tell it. So the SI unit of G is, so before going to discuss about this we should have to know the dimensions are units of force, unit of distance, unit of mass. So that unit of force is nothing but Newton, so distance which we can measure in terms of meter, and masses m1 m2 which is nothing but kg into kg, we can get it as kg square. With the help of this the SI unit of universal gravitational constant is Newton meter square kg to the power of -2, so which we can tell it. So in terms of CGS we have been taken, we can call it as dyne centimeter by gram square. So dimensions of capital G, so this is one of the important which you can go through once. So before going to discuss about this, first we should have to know the dimension formula of force, dimension formula of distance, dimension formula of mass. So with the help of that, so which you can write it as, so F into r square into m1 m2. So for force we have been taken, the dimension formula is nothing but m power 1 l power 1 t power -2, and the dimension formula for r is nothing but m power 0 l power 2 t power 0, because here power is 2 we are writing it as l power 2 by here m1 m2 masses, so m square l power 0 t power 0. So if you have been solve this, so we can get it as m power -1 l power 3 t power -2. This is a one physical quantity which is having negative power of mass. So most of the cases for all other physical quantities, so this mass dimension formula will be in terms of positive, but this is the one which you are going to get in terms of negative. So dimensions of G is nothing but m power -1 l power 3 t power -2. So value of G, so this value of G value is it is a constant 6.67 into 10 to the power of -11, and unit just now only have been proved, which is nothing but Newton meter square per kg square, so which we can get it. And in terms of CGS system, so we have been converted, So we can write it as 6.67 into 10 to the power of minus 8 dyne centimeter per gram square. Further one is a vector form of Newton's law of gravitation. So if you have been remembered, force is a vector quantity which is having both a magnitude and direction. So how we can write this in terms of vector form, so which we are going to discuss it now. So while discussing the force, at that time you have not been discussed any direction. What you have been said, force will be there between the two bodies like action and reaction. That means their forces are equal in magnitude but opposite in direction, so which we can see it. So with the help of this, so what we can tell it, so just you can go through once. Here they have been considered two bodies of masses m1 and m2. They have been separated by a small distance as a r, but force is a vector quantity which is having both magnitude and direction. r12 cap, it is a unit vector which specifies the direction. So this F12 which represents force on first body due to second body, whereas F21 represents force on second body because of first body. So and r21 cap is a unit vector. So now if you have been taken here as F21 force on second body due to first body, so here magnitude it won't be changed. Along with this, now we are going to discuss about its direction, that which is nothing but capital G into m1 m2 by r square along in a direction of r21 cap, r21 cap, so which we can tell this. In a similar manner, force on first body due to second body, so which we can tell it as, so capital G into m1 m2 by r square into r12 cap. So with this, so what we can observe that, so magnitudes they are equal, but r12 cap which is equals to minus r21 cap, so their directions are opposite. So F12 which is equals to minus F21 cap. So with this, so which we can represent the force in terms of a vector quantity which we can be represented. So gravitational force on a point mass due to the number of other point masses. Here I am considering one body which is having a mass m1 m2 under this condition, which I can tell it as they have been separated by a small distance r1, that unit vector is r12 cap. One more body I have been taken, that mass is m3. Under this condition, the distance between them is r13, which is denoted by r13 cap, so m4, like this, so which I have been considered for n number of particles, like this, so which I have been considered. Then what is a gravitational force? So this gravitational force is a vector quantity having both magnitude and direction. So while discussing the force between m1 and m2, we are not considering about the other point masses. So that based on principle of superposition. So with the help of that, now which we are going to prove it. m1 is a given mass. So m2, m3, m4, m5, m6 are other point masses around m1. So these are the distances which I can take it as r12, r13, r14, r15, r16 cap are the unit position vectors, and their masses which they have been taken it as respectively, like this. So while discussing this, first we are discussing only between m1 and m2. So under that condition, F12 is equals to capital G into m1 m2 by r12 square into r12 cap. This r12 cap is nothing but which tells the direction. similarly, which I can write it as like this. So for F13, F14, F15, so which we can do it. So by adding all this, the resultant gravitational force on M1, so F bar is equals to F12 bar plus F13 bar plus F14 bar plus F15 bar plus F16, so which we can get it. By adding all this, which we can get it in this. So this much of equation we are not able to remember. The equations which you can write in terms of summation form also. That summation form, if you want, means we can write it as F is equals to summation of capital G is a constant. So M1 M2 by R12 cap square. So this we can write in terms of summation form.